Hi! Let's solve story problems for rational equations. I will first go over how to set out the equations for these problems, and then I will have a different set of videos on actually solving the equations. Let's take a look at number 1. So it says, a boat can travel 15 miles downstream in the same amount of time that it can travel 9 miles upstream. If we know the speed of the current is equal to 4 miles per hour, so this is the speed of the water is 4 miles per hour. We would like to know what's the speed of the boat when there is no current, in the still water. So let's see. This question involves two situations. When the boat is going downstream, down with the water, or when the boat is going upstream, when it's going up against the water. And notice that this question talks about the distance, the speed, and the time. So it's going to involve this formula here. We know the rate times time equals to distance. Okay, so whenever you are dealing with the questions that talks about time, distance, and speed, we are going to use this relationship between the rate, the time, and the distance. So this is how we are going to set out the table first. Okay, we are going to produce a table to organize our information. So let's see, how can we figure out the speed when the boat is going down with the water? Let's take a look at the picture. So as you can see that when the boat is going down with the water is actually helping the boat to go faster, right? Because they are going, the water is pushing the boat down even faster than it would normally go. Well, for the downstream speed, we are just going to add up these two numbers, b plus c, where b is the speed of the boat and c is the speed of the current. So in here, we do not know what's the speed of the boat in still water. So for the downstream case, let me put on b first. But then I need to add the speed of the current. And right here it says the current is 4 miles per hour. So we are just going to do the b and then plus 4. Okay, so that will produce the speed of the boat when it's going down with the water. And now let's look at the upstream situation. When the boat is going up, but the water is pushing the boat down. So the speed will be slower in compared to the normal speed. The upstream speed will be b minus c. B stands for the speed of the boat in still water, and c is the speed of the water, the current. Okay, so b minus c, and we know the current is equal to 4 miles per hour in our question. So in here we will have b minus 4. Okay, so that's how we can figure out the speed for these two boxes, for the downstream and the upstream situations. And now let me go with the distance, because we can find the distance from the question. It says the boat can travel 15 miles downstream. So the 15 right here, the 15 downstream here, goes right here. Downstream distance. And then it also says that it travels 9 miles upstream. So upstream distance is equal to 9. So far this is all we have. These are the information that we can get from the question. Now we need to figure out the times though. Well, we don't want to create a different variable because we can do it, but I'm not going to create different variables. We can actually get a way of using a different variable. This is how we can do it. So we know that rate times time is equal to distance right here, right? Rate times time is equal to distance. Well, if we know the rate and if we know the time, what we can do is divide both sides by the rate. And we know t will be distance over whatever the rate is. So we are going to use this relationship to help us create, to fill in these boxes. So for the time, we don't need to use a different variable, but we can just do the distance, which is 15, divided by the rate, which is b plus 4. So for this box, we have 15 over b plus 4. And likewise, for the time that's going upstream, we just need to take the distance, which is 9, divide by, we'll put it over b minus 4. 9 over b minus 4. So this is how we can fill in the chart, the table. Okay, and now let's see how can we come up with an equation. So it says Well, how are these two things related? It says right here, downstream in the same amount of time when it's going upstream. So this represents the time that it took to downstream, right, when it goes downstream. And this represents the time that the boat took to go upstream. They are equal, and that's how we can come up with an equation on this. So for the first question, the equation that we need to solve is 15 over b plus 4, which is this box. We will just need to set it equal to this box right here. 9 over b minus 4. And ta-da! This is the equations that we need to solve. Okay? This is the equation that we need to solve.